Hello, this is Cedric Aquino. I'm on Honors Biology, Period 1. This is my Axolotl Punnett squares video explained. Okay, so I'm going to be choosing cross A. So these are the Axolotl parents for cross A. On the right side is the GFP golden axolotl, and on the left is a normal golden axolotl. Okay, as you can see here, parent 1 is the golden one. I mean the GFP golden one, and parent 2 is the golden one. The normal one. Okay, so based on the parents' appearances, I can guess that for iridophores, the possible axolotl genotypes are cross 3, cross 2, and cross 6, since producing iridophores is a dominant trait. For GFP, the possible crosses are cross 1 and cross 4, since parent 2 does not have GFP, then he's homozygous recessive, and the other one is either homozygous dominant or heterozygous. So since both axolotls are golden, then they are unable to produce melanin, which would mean that both of them are homozygous recessive for melanin. Okay, so these are the axolotl offspring. So the axolotl offspring include albinos, goldens, GFP goldens, and GFP albinos. Let me go back to the picture here so you can see. So I know it's a little bit blurred, so it's just the camera, my bad. Okay, so the percentages are 5% albino, 55% golden, 5% GFP albino, and 34% GFP golden. So the majority of the offspring can produce iridophores and only a few cannot. Close to half of the offspring have a GFP trait. So it's like 84% to 10% or 16% for the golden to albino ratio, and like 38% to 60% for the GFP ratio. So for melanin explanations, since both the axolotl parents do not produce melanin, their genotypes would have to be both homozygous recessive. For genotype, cross 5 or MM times MM is only the possible cross. Here you can see parent 1 and parent 2, like both you can see that there's 100% recessive trait, so that explains why the offspring do not produce any melanin as well. So for iridophores, both axolotls produce iridophores which show a gold and shiny color. The possible crosses are cross 6, which is heterozygous to heterozygous, cross 2, which is heterozygous to homozygous dominant, and cross 3, which is homozygous dominant to homozygous dominant. Since some of the offspring are albino and are unable to produce iridophores, that would mean that the genotypes of the parents would have to be able to produce recessive trait, since albinos would mean that they produce neither melanin nor iridophores. So the only possible cross for this is cross 6 or heterozygous to heterozygous. The cross 6 has a 25% chance of producing a recessive trait, which can explain the ratio of golden to albino axolotl offspring. Okay, so here's the Punnett square for iridophores. Here's parent 1 who is heterozygous and parent 2 who's heterozygous. As you can see, there's a 25% chance the offspring would be homozygous dominant. There's 50% chance it will be a heterozygous dominant. Heterozygous dominant, and there's a 25% chance it would be recessive, which is like a 75% dominant chance and a 25% recessive chance. Okay, so for GFP explanation, one of the parent was unable to produce GFP, meaning it has to be homozygous recessive, since producing GFP is a dominant trait. With one genotype shown, the possible crosses are cross 4, which is homozygous recessive to heterozygous, and cross 1, which is homozygous recessive to homozygous dominant. So, looking at the offspring contain the half having GFP and half not producing GFP. This would mean that the other axolotl would have to be heterozygous in order to produce a recessive trait with the homozygous recessive axolotl. So, the possible cross is cross 4 or homozygous recessive to heterozygous, since there is a 50% chance recessive and a 50% chance dominant trait. Because as shown in the offspring, like there are offspring that do not have GFP and some have one. So it has to be heterozygous for it to produce GFP. So here's the Punnett square, parent 1 being heterozygous and having GFP, and parent 2 not producing GFP and being homozygous recessive. So as you can see on the left side of the table, there's a 50% chance it's gonna be heterozygous, and there's a 50% chance it's gonna be homozygous recessive. Okay, for leucism explanation, since the parents and its offspring do not produce melanin, I cannot tell whether leucism is dominant or recessive. Okay, so for the end results, we can see that for parent 1, its melanin is homozygous recessive, the iridophores is heterozygous, the GFP is heterozygous, and the leucism is unknown. Okay, for parent 2, its genotype is also homozygous recessive. The parent 1 to parent 2, the GFP is the only one that's different. So for GFP on parent 2, it's homozygous recessive. Okay, so that's it. Thank you for watching. I hope you enjoyed this video and look at this happy looking axolotl. Thank you.